Hey guys, welcome to this topics video where as I was making this or thinking about making this, I didn't realize I didn't read the question correctly, which kind of made the question a little more interesting to me. Um, so I'm just going to show you how I took this problem and kind of messed around with GeoGebra a little bit. But it was kind of cool because it opened up a window, I think, for discussion and some curiosity sort of things. So this one says determine the values of c and d for which this equation, square root of 3x plus 1 minus square root of cx plus d equals 0, has no solutions. And then you have to enter the value of c and d in the boxes here. Okay, so the first thing that I did when I took this was, okay, this seems like a good GeoGebra question. I can make a slider for C and a slider for D and put this equation in there and just see what it looks like and then see what C and D do to the graph, right? So I got a GeoGebra window open and I just put the problem on here so that we can see what we're doing for the video. So the first thing that I did was I grabbed my slider tool and I'm just going to put a slider for C. And then the values, we'll just make it from negative 20 to 20. And we'll just jump by ones. So there's my C slider. Here's my D slider. Same deal. We'll just go from negative 20 to 20. Oops. Going by ones. And then you can change the color if you wanted to. That seems weird. There we go. Okay, so there's my sliders for C and D. So now what I thought was, well, let's just enter this equation and see what we get. So for the square root, you have to use SQRT and then use the parentheses. And then in the parentheses, we're going to take the square root of 3x plus 1. So that little notation down here looks like squirt. And then tell what we're taking the square root of, and then minus the squirt, or square root of. And now that we have C and D, we can say C times x plus d. And I like to use the asterisk because I think sometimes putting variables next to each other kind of confuses GeoGebra sometimes. So I just use the asterisk just to make sure I'm always good. So when I hit enter, this is the equation I get. And notice the equation has a solution because we're trying to find a value of C and D where this equation doesn't equal 0. So here it does at 0, 0. So as we move the sliders around, you can see the graph move, which is pretty neat. So there's a bunch of different looking graphs as we move our sliders around. Kind of interesting. Looks like some arc trig stuff here. Anyways, we want to get it like here, I think would work, where we don't have a solution where the graph doesn't equal 0 or cross the x-axis. So this, I think, would be a solution where C is 1 and D is 0. But then I started thinking as I was playing around with this, like, what does this graph even mean? What's it even doing? Because I know that even as a math teacher, I look at this and kind of have really no idea what this graph's going to look like, especially as I move C and D around to get some pretty funky things happening. So then I thought, okay, well, let's actually graph the square root of 3x plus 1 and then graph the square root of cx plus d separately and then take a look what the subtraction means. So I'm going to hide my function here. And so I'm going to just enter the square root, or the squirt, of 3x plus 1 and hit enter. So there's what that graph looks like. And for this problem, I don't want it to change. So you can sometimes, not on purpose, but grab your graph and move it around, which changes the equation. You can see it up in the algebra window. But sometimes we don't want that to happen, like now. I want this to be 3x plus 1. So I'm just going to right-click my function over in the algebra window. I'm going to go to its properties, and then I'm going to fix the object. So when you cancel out of there, no matter what you want to do to the graph, it won't move. You can still change its properties. Like, since I'm going to look at this function, square root of 3x plus 1, and then this other one, I'm going to make them stand out a little bit. So you can still do that even though the object's fixed. So there's my square root of 3x plus 1. So now I'm going to enter the square root of c times x plus d, and there's that graph of what my c and d are set to. And it kind of shows you the simplified version a little bit in the algebra window. So let's make that say red. Okay, so there's my two functions, right? So now as I move c and d around, I can see how it affects just that square root function itself. So c is kind of a stretching factor, and when c is negative, the graph flips. And then d, when we move d around, oh, that just translates our graph horizontally. So the question is, find a solution where we could take the outputs of this graph and subtract it from the outputs of this graph and see what that graph looks like. So this is kind of a calculus idea, I think, that you can find the difference. So what I'm going to do is I'm going to create a third slider, and we'll call it x. So what that's going to allow us to do is slide a point based off of an x value. And then we're going to set a couple points on each graph here so we can find the difference between these two functions. So I'm just going to type in the input bar. Instead of actually putting a point, I'm going to define a point, which you don't have to use the label. You can just start your point with a parenthesis, and GeoGebra will go ahead and label our point for us when we hit enter. But the x-coordinate, oh, I need my slider first. So I'll just put this down here maybe. GeoGebra reserves x for functions, so when I want to use an x, I use a capital X for my slider. That way it doesn't confuse GeoGebra. Since my window is only going from, looks like -5, I'll start at that. And then the max looks like 14. I'll start at, or make that my max, and then my increment will jump by 0.1 works. Okay. So there's my x. So now what that allows us to do is create a point that we can move with this slider by making the x-coordinate whatever x is. So capital X, comma. And then I want to evaluate my g of x. That's that green graph. So I'm just going to say g of our x, capital X. So when I hit enter, we have a point whose x-coordinate is this x-coordinate, and as I slide it, notice it just evaluates itself, so it just moves along that curve as we move our slider around. I'm going to do the same thing in this function. This function is h of x, so I'm going to do my point at x as the x-coordinate and evaluate the h function with x. Hit enter, and now we got 2 points that are going to be at the same x value, and they're just following their own graphs because we're evaluating each function at that x value. So now this function is saying let's subtract them. Let's find the difference between these two outputs. So c has this longer output, d has this shorter output. So if we subtract d, or this point from h of x, from this point from our g of x, what we get left over is this little segment here. So I'm going to grab my segment tool, and I'm actually going to make a segment between those 2 points. And then to see the difference, it's just going to be the segment length, right? So I'm going to go to this angle toolbox here and open it up and see the distance or length tool. So I'm going to grab that tool, and I'm just going to click on my segment, which gives me the difference between those two. So the cool thing now is that when I slide x around, notice that difference changes, right? And then we get to a point too where we don't have a defined point on one of the functions. So maybe that's going to be a no solution too. But where do these two, the difference of these two, not or equal to 0, not have a solution? Well, let's see what this graph looks like. So notice when you use the distance tool, A gets formed here. That's going to be the length, and it has value to it. So now what we can do is create a new point. It's going to have the same x-coordinate, and then the output length is going to be the segment length. That's really the difference between both our functions, right? So I'm going to say just A for the y-coordinate here. So when I hit enter, notice the difference is 1.16, and that's exactly what the output is or the y coordinate of this new point, right? So this is actually going to follow our function. So maybe I'll make this point stand out a little bit. Make it blue and a little bit bigger. So now as we slide x around, notice that difference is just plotted as a point, and we can see that E is following some kind of curve. So we can right click the point E and we can turn the trace on. Pretty cool feature in GeoGebra. So if we turn your trace on and then slide x around, it'll just leave a little dot of where E has been. So you can see here that it follows some kind of path, and then when you turn your function back on, the one we had at the beginning, notice that function goes right through our points. Pretty neat. So we can hit Control, I'll go up to View, Refresh Views if you want to get rid of your trace dots. So Control F. So now we can just change our sliders around. So now we can see the curve that, I'm going to hit Control F here, the curve that our difference will follow. And notice there is no solution on that curve. It doesn't cross the x-axis anywhere. Maybe it does way over here. It's like an asymptote. So as we move this around, you can see the difference, and then when we get to this point, there is no more defined difference. And then the graphs will never touch each other. So anyways, taking a problem like this, it seems kind of complicated, and kind of see the potential that GeoGebra has for discussion. Not only for, you with your students, but I think it's important for us teachers to go, man, this is kind of neat, just to see what this function is actually doing and kind of investigate it and see what the mathematics is, so that maybe we can create a lesson that we can teach our students that we never seen before or even thought about before, which I think is a pretty cool power of GeoGebra itself. So anyways, I hope that kind of made sense. I'm just lead you through some kind of curiosity investigation sort of based off of a problem. Thank you guys.